The electromagnetic spectrum explained. Have you ever wondered how you can see, text, listen to music on the radio, and even heat your food, all thanks to waves? Today, let's talk about the electromagnetic spectrum, a family of waves that travel through space without needing any medium. For electromagnetic waves, the speed is always the same, the speed of light, about 3 times 10 to the 8 meters per second. When a wave's wavelength is longer, its frequency becomes lower, and when the wavelength is shorter, frequency goes higher. So basically, wavelength and frequency are like a seesaw. When one goes up, the other goes down. Now, all electromagnetic waves, or EM waves for short, travel at the same speed, the speed of light. That's super fast, around 300,000 kilometers per second. So what makes electromagnetic waves special? Unlike sound or water waves, they don't need a medium. They can travel through space, even a vacuum. That's how sunlight reaches Earth, even though there's no air in space. These EM waves come in a whole range of types, from really long ones used for communication to really short, powerful ones used in medicine. We call this range the electromagnetic spectrum. Let's explore the spectrum from the lowest to the highest frequency. 1. Radio waves. These have the longest wavelength and lowest frequency, used in radios, TV broadcasts, and cell towers. So every time you tune in to your favorite FM station, that's radio waves in action. 2. Microwaves, a bit shorter in wavelength, but higher in frequency. They make your food warm inside the microwave oven, and they also help your phone connect to Wi-Fi and satellites. Next, we have infrared rays. Infrared means below red. You can't see them, but you feel them as heat, used in thermal cameras and TV remote controls. So, when you press your remote, infrared waves send the signal to your TV. 4. Visible light. This is the only part of the spectrum our eyes can detect. It includes all the colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. From red, the longest wavelength, to violet, the shortest wavelength. Number 5. Ultraviolet rays. These have higher frequency than visible light. The sun emits UV rays. Small doses help our body make vitamin D, but too much can cause sunburn or even skin damage. Now, we're in the high energy zone. X-rays can pass through soft tissue but not bones. That's why doctors use them to see what's inside your body. And the last, gamma rays. These have the shortest wavelength and the highest frequency. They carry a lot of energy, powerful enough to kill cancer cells and sterilize medical tools. So what's the main difference among all these waves? Just the wavelength and frequency. They all travel at the speed of light, but the amount of energy they carry increases as the wavelength gets shorter. From low-energy radio waves to high-energy gamma rays, that's the full electromagnetic spectrum. Let's think about it this way. Everyday life is filled with EM waves. When you use your phone, when you watch TV, when you feel the warmth of the sun, when the doctor checks your bones, you're actually interacting with different parts of the electromagnetic spectrum. Pretty cool, right? So, to summarize, next time you listen to music, take a selfie, or look at the stars, remember you're surrounded by invisible waves, all part of the same amazing electromagnetic spectrum. That's all for now. I hope you learned something today. Thank you for watching. Till next video.